Hey class, this week's lab, and actually this week and next week, we're going to be working on the same lab. It's called the Central versus Peripheral Fatigue Lab. And if you don't know what that is, I'm just going to give you a very brief summary. In class, I'll talk a little bit more about it, but not too much. I kind of want you to figure out a lot of this stuff on your own. Whenever we're exercising, we get tired, and many exercise physiologists somewhat disagree on where the genesis or origin of us getting tired is. So, some individuals in the central fatigue camp, they think that your fatigue begins in your brain or spinal column, so somewhere in the central nervous system. Other individuals think that peripheral fatigue is where it actually begins, and peripheral fatigue is more or less accumulating metabolites like lactate or hydrogen ions inside of your muscle cells, or sometimes even your peripheral nervous system might have an error in the messaging. But those are just the two general areas where fatigue could start. So one being essentially in your brain or spinal cord, I'm sorry, or peripherally, so like actually in the muscle or thereabouts. So this lab will be different than the other labs in the sense that you're actually going to be writing a paper rather than collecting some data, making a couple of graphs, and then answering some questions. So I want to read this to you right here. Um, you will actually have to write a paper um, rather than our typical lab format. One big thing, do not turn in the same paper as your group. You must write this paper on your own. Now, I do know that since you're working in groups, you're going to have the same data or information, but that's really the only place where you should have similar parts. Everything else you need to write on your own. So this is probably the most individual project that we're doing in here. How I'm going to grade this, you can look at the rubric down here. So there's a focus and thesis aspect that's more or less staying on topic. Gosh, that interpretation right there, that N, I just wanted to go over it. Well, it won't. So you'll know how interpretation goes. Sorry, going back to this. Focus and thesis, there's that aspect of it. Analysis and interpretation, organization and coherence, evidence and documentation, and then language use and conventions. So all of that together, read all of these. We have three different categories of accomplished, that more or less being 100%. Competent, that's somewhere around a B, and then developing, that's a lower grade. And I'll grade you on all of those for this that we're going through. So getting down to more what the paper is going to look like, you're going to write this paper in 6 sections. So there's going to be a background, methods, results, conclusions, pontifications, and references. So I just wanted to go through this so you really know what's going on. So this part right here, background. For this section, you will need to provide background on what we are testing and cite at least one peer-reviewed scholarly paper. Do not use quotations whenever you're doing the in-text citation. You need to paraphrase it. If I see any quotations around anything, I'm going to dock you points. So you must include at least one in-text citation. Also, there should be multiple paragraphs. You need to write this in a way that an individual not in the class would understand what we're talking about. So explaining what central and peripheral fatigue are. So go more in depth than how I went a little while ago. Do some research to figure that out. An example of an in-text citation, it kind of looks like this. So here's something that I found a little while ago. So past research suggests that too much exercise can damage the heart. And then I provide a citation. So the names of people and the comma of the year. So if there's more than 2 or 3 people on there, you would just put et al. In Latin, that means and others. So you would do that if there's more than 3 individuals on the paper that you're actually citing. If you've never found an academic peer-reviewed paper before, here's how you do it. So you go to Google Scholar. What am I even looking at? That's weird. Okay, so here's what Google Scholar is. So scholar.google.com. Here you would type in something like central. Oh gosh, it's like I already typed this in before. So central and peripheral fatigue, and you could put and exercise, for example, and then press enter. And then there we go. We find a bunch of things. So right here, central and peripheral fatigue, interaction during cycling exercise in humans. You can click on that and then read the paper. So that's why this is taking 2 weeks, because you'll have to read at least one whole paper. Now, how you get a reference on this, which is one of the last sections, this right here, where it says cite, click on that, and then this APA part right here, you can just click on it, do Control or Command C, then back to our paper, and then here, paste it in. There we go. That is an APA citation. And like sometimes the ones that you get from Google Scholar are a little bit off, but I will not take off points if yours are a little bit off. Just make sure to get it from Google Scholar. So that's how that goes. This next part right here, the methods section. So you'll write out how you tested central and peripheral fatigue. Down here, I put kind of bullet points on how to actually test it. So read these, but you need to put this into like paragraph format. So something important is that you need at least 4 members of your group to do both central and peripheral fatigue, like interventions. Now, we're doing 2 different things to assess central fatigue and 2 different things to assess peripheral fatigue. So, for central fatigue, you'll either be holding a weight or doing a wall sit. Now, one time you do it, you'll do it with either your eyes closed or eyes open, and read this for some explanation there. So 1 week you'll do one of them, and the next week you'll do the other one. For peripheral fatigue, what you'll do is do bicep curls with, the bar or a weight that we have in the lab, and you'll do them to the pace of a metronome. One time you're going to have a blood pressure cuff inflated to 80 millimeters of mercury around your upper arm. The other time you won't. So say the first time you go in, you'll do it with the same weight with the blood pressure cuff on, then the following week you would do it with it off. So we'll be doing both of these essentially at the same time. If that doesn't make sense to you, talk to me in lab and I'll try to make more sense. So that's how that's going to go. This next part, the results section, you're going to need to provide 2 graphs and an interpretation of both graphs. If you've never done much with statistics before, that's okay. How I have this set up, I assume that you haven't done anything with statistics before, but it's actually fairly easy to interpret. So looking at this results section, let's why don't we make our Excel sheet? Okay. Sorry, that came over to the wrong screen. Okay, so here's what we're going to do. So central fatigue. You're going to be measuring this in seconds. So one time, eyes open, and the next time, eyes closed. So type this along with me if just so you have everything. So have this be person 1, and you can actually drag this down, person through 4. Copy that to right there. So good there. Now let's do a mean and standard deviation. So let's bold that just so we can see it really well. So put the equal sign here, average, open parentheses, highlight all of that, close, done. Standard deviation, equal sign, STDEV, open parentheses, highlight all of it. Oh man, sorry, miscalculated, or I didn't miscalculate. There we go. So standard deviation right there. So we have both of those, and you can copy those and place them right here. So we'll have that. Copy it to right over here, and then this, put peripheral. Gosh, I hope I spelled peripheral right. And for peripheral fatigue, since we're doing bicep curls, it's going to be reps instead. So good. There we go. Let's just make up some numbers so that we can kind of see what's going on here. So let's say that with your eyes open, you can do 25 seconds, but the next time you come in, 22 seconds. Here, someone a little bit better, 33 seconds, but it goes down to 24. Here, about 38 seconds, and then this, 33. And then here, 40, and then 42. Because that one goes up for whatever reason, because that happens sometimes. So how I said the p-value on that last one, p-value, let's look at that. So how we assess that, enter equal sign, or don't press enter, just press the equal sign. So type this, T, E, E, S, E. Then open parentheses, highlight this first array, comma, array 2, highlight that. Oh, geez. Sorry. I wish one of y'all would have corrected me. Okay. So what I did there, don't highlight the mean, only highlight the 4 individuals. Over here, highlight these 4 individuals. Now, comma, I'm not going to explain to you what a 1 and 2-tailed distribution is. Just know that generally people do a 2-tailed distribution. So press 2, and then comma, and then here, since if you take research methods with me, I'll explain this more, but it's paired. So it's a 1. Close the parentheses, there. There we go. So there, remember that it has to be right here, less than or equal to 0.05 for it to be statistically significant. So if you have values like this, it is not statistically significant. So this next part, I want you to enter different things. So mean difference, and you can just put diff right there, and then pooled standard deviation. And the reason we're doing that is because a mean difference and a pooled standard deviation, that's going to give us our effect size, which is just called a Cohen's d. Now, this p-value, what that means is if these numbers are statistically significant. This Cohen's d, this effect size, it's going to tell us the magnitude of difference between these two. And it's getting at a question of meaning. How meaningfully different are these two numbers? So, yeah, I'll show you that here in a second. So first thing, mean difference. So enter the equal sign. Highlight that, mean difference, minus that, minus the second mean. So equal sign. So we have 3.75. So next thing, pooled standard deviation. This is actually a relatively complex formula that you're going to enter in here. So please follow along with me as best as you possibly can. To start off with, we're going to square root this, SQRT. So type that SQRT, open parenthesis. So we did that. Open another parenthesis. So you should have, another color of it. Click on this first standard deviation. And you're going to have to make an exponent with it. So shift 6. So that little like triangle thing right there. If you have difficulty finding that, like just talk to me in lab and I'll show you. It should be shift 6 on a typical like HPs and things. 2 plus this second standard deviation, shift 6, 2, close the parentheses, and then divide it by 2, and then close the parentheses. So there, it's first standard deviation to the second power plus the second standard deviation to the second power divided by 2 while square rooting all of it. Enter that. There we go. Okay. Now, what the Cohen's d is just equal to the mean difference divided by the pooled standard deviation. There we go. 0.467. Okay, now that might not mean anything to you, but if you read this over here, it should make some sense. A small effect. So here, if we're interpreting this, we would say that closing your eyes has a small effect on fatigue, yet not statistically significant. So just for just so you can see this, Cohen's d, small, medium, and large. So here it's 0.8, 0.5, and 0.2. So there, and in case you're wondering about any of that. So this, we can actually copy it and paste it right here. And this should work pretty well. So let's just, oh, no cuff, cuff. Sorry, yes, correct that. So the time where there's no cuff and there is a cuff. So now you should have this entered so you don't have to worry about calculating it all again. Good. Okay. So let's just come up with some random numbers. So let's say you can do 15 reps with no cuff on, but with the cuff you get 12. Here another person 11, they go to 8. 10, 12, How about 8 and 9? How about that? So here we actually got a significant p-value, so meaning that these sets are statistically significantly different from each other. And the Cohen's d, that is a large effect right there. So next things I'm going to want you to do, enter some graphs. So I said line graphs. There we go with that. So this one is central fatigue. So some other things we're going to have to add. Axis titles. That one and that one. Okay. So here, trial. And here, seconds. So here with this trial, click on select data. Here, click on edit. I think this should work. So eyes open. Then I did a semicolon, eyes closed. Yep. Really happy that that worked. So how I did that, in case, oh, did that not change? Okay. Select data. So clicked on that, select data, right here, horizontal category, edit. Axis label range, eyes open, semicolon, eyes closed. Press OK. OK. Good. There we go with that. Let's add some, not trend lines, error bars. That's what I want. More error bar options. We're going to have both plus and minus, and we're going to need some custom ranges. So specify the value. In this positive, you're going to click on that, hold down Shift or Command, click on that one. Then for negative, do it again. So I highlighted the negative error value, click on the first standard deviation, hold down Control, do the next one. Yeah. Did that not work? Yeah. It's not working for us. Okay, so here I'm going to try that again. So specify the value. Okay, so we got the positive ones. Okay, so these negative ones. Okay, that's what you need to do. I'm sorry. Delete that. Click on the first one, hold down Shift or Command, click on the second one. There we go. There, that works. Just in case any of y'all are wondering, I almost always do these in one take. So that's, and I'm doing it in one take so far today. All right. So central fatigue, that's what that looks like. Again, we got a small effect size there and a non-statistically significantly different p-value. Next thing, click on the mean here, Control, click on the mean there, insert. Let's do this. Follow along, and again, pause anytime you need to. Add these things. Let's add axis titles first. Okay, so here, You can put reps or repetitions. I'm just not writing repetitions because I always have a hard time spelling it. So here, trial. Now, why am I clicking on that? Trial. All right. Then click here, select data, and then edit. No cuff, semicolon, cuff. Press OK. There we go. And let us add these error bars. More error bar options. We're going to do both. Cap, custom, specify. Let's do this top one. That standard deviation, controller command, that standard deviation. This one down here, delete it, because I'm not going to make that mistake again. That standard deviation, control, that standard deviation. Press enter. There we go. So we have that. We assessed, we're assessing central and peripheral fatigue. Those are the graphs and the statistics that you're going to have to do to interpret it. Now, if you have problems like interpreting it, I can certainly help you. Going back to here, so that's really how you're going to write the results section. One interpretation paragraph for each graph. Next thing right here, for this section, conclude, in the conclusion section, conclude which of the two fatigue paradigms had the greatest effect based on effect size and percent change. So what does this mean for why we get fatigued? Like address the problem. So if we're just looking at effect size, peripheral had the highest effect size, being a large one, a relatively robust effect size. So let's go over here and remind you how to calculate percent change. So what was that percent change? Okay, so it's equal to your first one minus your second one. Yeah, and you're gonna need to put parentheses around that, divided by your first one, and then multiply by 100. Okay, yes. So that right there, that is a 11% decline with the eyes closed. Is that right? Yeah. Yep. There we go. So you see it's 11% decline because the percentage there, that's an 11% drop. And so yeah, 11%. Let's copy and paste this one to right here. Let's see if it goes right in. Okay. This one right here, it's looking at that mean and that mean. Make sure whenever you copy and paste, stay within the row, because then you don't have to type it in so many times. So here, that is a 22% drop, almost a quarter drop with the cuff on. So that's how you can run that math. All right. So with that, what does this mean for why we get fatigued, at least based on the data that you got? So answer that based on your data, not mine, and then address if there are any problems that you obtained. Like like the people in your group, like say they weren't trying hard enough on a particular trial, or say they said something about they didn't sleep very well, or they haven't eaten in a long period of time. All of those could uh, alter how this data actually shakes out. So that could happen. Next thing, pontifications. This. Um, Here's my question for you: Is the Flash? And I grew up with Wally West version, so if anybody watches like the Flash on the CW, that's Barry Allen, which also a great Flash. But I grew up with Wally West, and I think he's a little bit faster. Um, so is he a great superhero or the greatest superhero? And if you don't think he's a great or greatest superhero, well, I feel sorry for you. Uh, in this volume and issue of the Flash, he ran trans time velocity, and if you don't know what trans time velocity is, look it up. It's interesting. Um, it's faster than teleportation. It's pretty intense. So answer that question. Next thing, references. Um, make sure to provide a reference using hanging indent and to put sources in alphabetical order. So you can use more than one reference, but uh, use at least one. And if you don't know how I did that, um, what you do is you highlight it, you click on, I think it's right here, line, spacing, paragraph. Yeah, line spacing options. Okay, yes. So you click on that, indents and spacing. Here under the special, there's first line, there's none, and there's hanging. So click on that. Okay, hanging indent. That's how that goes. Um, Hopefully all this makes sense. This really not a lot of data that you're taking. The reason though we're taking 2 weeks with it is because there's a fair bit of writing with it. So great. Thank you. See you in class.